We have that covered in the room here. I think Mally is doing that. Yes, thank you.
Yeah, yeah, I'll help her as well. Yeah.
That's great. Thank you. Okay, now in terms of what we want to accomplish with this session is first to help with a wider understanding of Data Connect, what it is, maybe what it isn't, and how you can get started depending on where you are now with the data sets that you'd like to share or publish. And of course, we're always looking for more collaborators. Everyone's invited to join our meetings during the effort, or just to ask for help, and we'd be happy to work with you to figure out a good implementation path. In terms of the agenda, I think we're in the welcome and introduction section. Ian, would you like to introduce yourself?
Yeah, I'm Ian Four. I'm with the National Cancer Institute in the US. I'm the co-chair of the FASP initiative and project champion for the Cancer Research Data Commons, which is a GA4GH driver project.
Great, thanks.
And you know, I don't have an official role on Data Connect, but I'm a big advocate and user of it and provided use cases for it.
Great, thank you. I'm Jonathan Firth. I'm a director of engineering at DNA Stack, and through DNA Stack, I'm also working with the Autism Sharing Initiative with many of the partners there, helping with technology enablement and other things. And Autism Sharing Initiative is one of the GA4GH driver projects. And I've also been a contributor to Data Connect, I guess since its inception, although I think I also don't have an official role on the project. Yeah, that's my intro. And then in terms of the rest of the agenda, we'll kind of step through some different Data Connect adoption scenarios, starting from maybe the most basic, simplest, and then up to some more and more sophisticated, and actually ending with sort of questions for the room about where should we go next. So I guess we can go to the next slide. Okay, so what is Data Connect? So I guess you could almost think at the beginning, Data Connect is almost like a paginated CSV files. I think the two big differences that you would find beyond CSV files is that you can have some structure to the data. So it's not just flat values like strings and numbers. You can have embedded JSON within a row of a table in Data Connect. And the other really important thing that distinguishes Data Connect from something like CSV or a spreadsheet is that the model of a row is defined by a JSON schema that comes with the table. So when you get a Data Connect table from somewhere, it will come not only with the data and the column names, but also a richer description of the format of a column. And that can touch on semantics to a greater or lesser extent. And that's what we'll be exploring in Ian's part. And importantly, the second major point here is that Data Connect doesn't prescribe the data model that you should be using. It just says how to describe your data model. And you will bring your own data model. So you could choose a model that you're maybe already using in your data set, or you could choose to choose some model that was defined externally that's maybe being used by many different projects and relate your data to that model. And again, we'll get into what that looks like in Ian's part. Go to the next slide. So here's a high-level overview of what a Data Connect ecosystem would look like. So you can see Data Connect is there in the middle as the kind of middleware API between a bunch of use cases along the top, different data consumer activities like working with data through a Jupyter notebook. I think we'll see some of that later through maybe web-based data explorer tools. You can even implement higher level APIs like the Beacon API on top of Data Connect. And CLI tools, of course, if you're working with data in shell scripts or other kind of workflows that use shell scripting. And underneath Data Connect, you can see all sorts of different data sources that we've already implemented. So you can access data in all these different formats through the common API. And the big advantage there that you get no matter which level of harmonization you're going with is that now all these green squares at the top only need to speak one protocol in order to access all the data that's available in all these yellow squares at the bottom. And now getting into sort of the main topic of this session with the levels of harmonization and the levels of where you can start with Data Connect, depending on where you are. If we start at the bottom of this chart, kind of the first door, if you have tabular data with column names, for example, CSV, TSV files, some sort of JSON arrays, you can start with Data Connect right away just by describing the structure of that data in a schema. This tends to be very low effort on the part of the publisher of the data. Just sort of start with what you have, describe it mechanically, and now sort of over on the right, you can see the benefit as what I had touched on earlier. Your data is available. It can be queried through a common API. People who are pulling this data need to be a little bit more like data detectives because column names aren't very much information, but at least you only need your tools to speak one language to pull data from a number of different sources. And yeah, sort of the many eyes make all bugs shallow type thing where once the data is out in the open, the people who are pulling it can work with each other to figure out what it means and build more tools and capabilities on top of that. So moving up to the second door here, you may have data that has some sort of a data dictionary, a model, a schema that describes the data in more detail than simply just column names. And here, it may not be harmonized in the sense that it doesn't conform to a model that any other data set uses, but it's a lot more information than just the names of columns. And so here we can translate whatever sort of data dictionary we have for data into a JSON schema. This also tends to be very easy, assuming you already have a data dictionary in some machine readable format. And now data scientists who are accessing your data have a much richer set of information available about what things mean. And then finally, the top door is if you have data that's already conformed to some externally defined schemas or concept libraries, then you can describe your data in full detail, relating each table or each column within a table to externally defined concepts that are actually used in common across many data sets that conform to that sort of knowledge organization system. And from here, data scientists, again, have a lot of specific information about what the data means, and it also enables a much richer set of tools because there's these machine readable correspondences between different data sets that someone might be working with. Okay. So Ian, is this a good place for you to take the reins?
Okay, I'll pick it up from here. Thanks, Jonathan. So I think the main thing that we're referencing here and what we're going to do in this session is actually walk through the three doors. That came out well, didn't it? Walk through doors. Walk through the three doors and see what that looks like so you get a better sense of what Data Connect is capable of when we talk about the things that we've described, because I think those things have been described previously, but we want to give people a better experience of that. Now, in the first case, we're really relying on something which I'm going to refer to as homework, which is there's a session recording, which is the Data Connect Quick Start, which is linked at the bottom. You could go and do it now, but we hope you'll stay in the session and listen to this for now, and maybe do that afterwards. That walks through, and Fiz Ahmed from DNA Stack recorded this as part of the FAST Hackathon back in January to show you what it takes to stand up the reference implementation of Data Connect and get it running. It's about a 26-minute video. And it goes through where you get the server from, how to install it, and run the Docker containers. And I'm really going to be starting here from where Fiz finished that with the Docker containers up and running. But just to, I think Jonathan's already covered, you know, where do you get to if you come in through door one? And yeah, your data is there as it is, but it does end up as being a higher effort for consumers of the data, the users of the data. They have to address, they're going to have to work out, well, what units is this column of weight expressed in? Maybe somebody put that in the column name, that would be nice. Maybe they didn't. Or maybe you see cryptic codes like 1, 2, and 3, and you're not going to get many clues about what those things mean. The detective work you would have to do would be variable. So we're not going to dwell on that, but what I am going to show is really, as part of looking at the second door, some of the things that Fiz showed in the Data Connect recording, and I'm going to do it live on moving to the second door. And in this situation, we're going to be in a better situation than that cryptic column name and not having those codes. The providers of the data in that situation are providing some kind of dictionary, and we'll look at a couple examples of how you would use that and make data available in Data Connect. So this is to illustrate, you know, referencing back to one of the earlier slides Jonathan showed, was this is a really important part of Data Connect. The fact that there are machine-readable schema and a format for the machine-readable schema, which is in JSON schema, that describe each of the sources. And this is in a Python notebook showing how you would call a Data Connect client for a particular table and get back the definitions of the fields, which is going to give you, in this case, the enumerated values for sex are not too tricky to deal with. Likewise for race. But you're going to find situations where those values might be coded by 1, 2, or 3, and we'll kind of look at some of those examples. So the first example we're going to look at comes from the Seneca data sets. And these are a set of synthetic data sets 4 data sets